Hey guys, welcome back to another video from Smart Interviews. So today we're going to discuss the problems under CodeChef Contest Starters 169. I'm Sanjay Kumar. Let's get started. If you look at the first problem, opposite attract. So you're given a binary string s of length n. Your task is to generate a new binary string of t of same length such that each corresponding character of t is different from the character of the same position s. That means, let us say if you're given a particular string, you're supposed to invert the particular character that is present in that particular place. If it is something like 0011, the output is 1100. Yeah, if it is 0, you're supposed to put a 1. If it is 1, you're supposed to put a 0. Let us look at constraints as well as input and output. The constraint says that the number of test cases can go maximum to 10 power 5 and can go maximum to 10. That means the string length can be maximum of size 10. Okay, input format, the first line of input contain the t number of test cases, and later for each and everything you're given n the size of the particular string length and later the string s. Yeah, so how can we solve this? We can just simply iterate on the particular string. If it is 0, just take 1 to the output. If it is 1, take 0 to the output. Very simple, right? Let us just complete this piece of logic. If you see here, this is the entire logic. I just took a scanner, t the number of test cases. For each and every test case, I'm trying to take input and later the particular string what we are required. I wanted to implement this function invert binary string, and I'm just trying to take it into the result, and I'm going to print this result. So this is invert binary string which we are going to implement now. So invert binary string. You're given a string s of length n. You're supposed to invert this entire string. You're supposed to invert this entire string such that if it is a 0, place it a 1. If it is a 1, place it as 0. Yes, very simple. So for this, if you can simply take a string builder, and if you can somehow build the entire string whatever we are required to the output, that will be very simple. So let me take a string builder. Let us say out is going to be new string builder. Yeah, so I need to iterate on this particular string so that if it is a 0, I need to take 1 to my output. So can I just simply say for, let us say this is a character c in, this is the string, s dot, I'm trying to convert this string to character array to character array. If this particular character, if c, if that is a 0, indicating that we are supposed to take 1 to my output. Out dot append 1, else out dot append a 0 to the output. And later, once we are done iterating on the entire string, whatever the character that we took, we inverted them, and later the thing is I'm supposed to return the string whatever we got. So I'm going to return out dot to string. So whatever we got, we're going to convert into string and on. So if you see string builder out equal to new string builder, I'm going to iterate on this particular character array. So to char array. So if it is a 0, I'm going to append 1. If it is 1, I'm going to append 0. Let us run this. And let us compare with the input and output. So this is the exact same input and we got output as 10101 and yes, let us submit this. Yeah, all the test cases got passed. So moving to the next problem, having equivalent. You're given a permutation P of length n. You are allowed to perform the following operation any number of times. Choose any two numbers Pi and Pj such that number of set bits is the same and swap them. Okay. Determine if it is possible to sort the permutation in ascending order using this operation. If possible, print yes. otherwise print no. Okay, let us look at the input format. You're given t, the number of test cases, later n, the value of, in the sense, the length of array, and later the permutation, the array permutation p. Output is just either yes or else no. If you look at the constraints, the t can go maximum 10 power 5, 10 power 5 test cases in max, and n can go maximum to 2 into 10 power 5, and the minimum value of n can be 1, in the sense a single element, maximum minimum of single element. And you all know what is a permutation. If it is a permutation of particular number, let us say 3, it may contain like 1, 2, 3, and the order may be in any of the way, like 3, 2, 1, 1, 3, 2, whatever the order. It is going to permutation. Somehow you are supposed to say whether you can just simply sort this in ascending order based on the condition given that you are supposed to pick two elements I, j, such that if the two elements have number of set bits which are same, you can just simply swap them. And this operation you can just simply perform as many number of times as you can. Yes. So if you look at this example, let us take the fourth example, 4132, and the output here we got as yes, 4132. So the input example that was given as 4132. 4132. So this is a permutation of length 4 for the value n is equals to 4. N is equals to 4. But if you see, and to somehow arrange this in ascending order by taking the conditions given such that pick two elements and swap them, and picking these elements in the sense only if they have equal number of set bits, and then I can just simply swap them. Let us see how many set bits do we have for each and every particular element. As it is something like 4, 1, 3, 2. For 4 we have something like 100. For 1 you're going to have something like 001. For 3 it is something like 011, and 2 it is something like 010. That means here we are having only one set bit, here we are having one set bit, here we are having two set bits, and here we are having one set bit. It clearly indicates that I can use the number 4, I can use the number 1, I can use the number 2 to pick any two pairs and swap them such that the entire array, in the sense the entire permutation, will be in ascending order. Yes. So that means, can I do something like this? Obviously one should go to this particular position, so if I want to replace, like if I want to swap 4 and 1, obviously these two numbers are having equal number of set bits, so I can just simply replace. It's going to be 1 4 3 2, 1 4 3 2. After the first iteration, let us say 1 has went into its sorted position and 3 is already present in its sorted position. So 1 is in its sorted position as well as 3 is in sorted position, and later the only thing that is left over, 2 should come at the index 1 and 1 should go to the index 3. That's it, right? Yeah. So for this sake, let me take this as 0 1 2 3. Yeah. So 2 should come here. So if you compare the number of set bits in 2, you're having 1. If you compare the number of set bits in 4, you're having 1. So obviously once again I'm having an option to swap these two elements, and in turn overall it's going to be 1 2 3 4, and overall entirely it is sorted 1 2 3 4. Yes. So this is the logic that was mentioned, and you're supposed to print true if you're somehow able to sort this entire array. If it is not possible, you're supposed to print false. Let us also take one other example to see if it is, like, based on how it is, it may not be possible. There is an output saying no. That example is 3 1 2. Let us take this example 3 1 2. For n is equals to 3, the example is 3 1 2. So obviously if you see, 1 should go to 0th index, 1 should go to its position. So if 1 should go to its position, obviously this element should be swapped with this element. But if you want to swap this element, we are supposed to compare the number of set bits. For 3 we are having 2 set bits, for 1 we are having only one set bit, and that is 001. And can we swap these two elements? Is that really possible? Obviously no. And if you take the 2, it is something like 010. We can somehow swap these elements 1 and 2 as many number of times as we want, but something like 3 2 1 or else 3 1 2, we can swap these elements 1 and 2 as many number of times, but entirely will that entire array, entire permutation, will that be sorted in ascending? Obviously no. So for this, you're supposed to print no, and for the above previous, you're supposed to print yes. So that is very simple. So how can we solve this? The logic is very simple. The logic is very simple. If you say this, if you say this, let us say, once again, I take this example 4, 1, 3, 2, 4, 1, 3, 2. And let me also take the indices. This is 0, this is 1, this is 2, and this is 3. And finally, the entire output should be something like 1, 2, 3, and 4. So, hope you remember the output should be 1, 2, 3, 4. At this particular point, if you see, 1 should go to 0th index. Once again, 1 should go to 0th index. So if you want to 1 should go to 0th index, obviously something should be swapped with the element that is present at 0th index. Hope you're able to understand. Something should be swapped. Okay, something should be swapped with the element that is present at 0th index. That may be 1, that may be 2, or that may be 3, something else, and later you're going to swap up, and later one is going to place at 0th index. So something you're supposed to swap with an element which is present at 4th index. Yes. So if you want, something you're supposed to swap an element which is present at 0th index, which is 4. So if you want to perform this, swapping operation, obviously the number 4 should contain the same number of set bits than the numbers that whatever we are going to swap with that contain, right? Yes. In the same manner, over here, if I want to swap with the number 1 directly, obviously the number of set bits this number 4 should contain should be equal to the number of set bits that 1 contains. I hope you are able to understand. That means for each and every element, the number of set bits should be equal to the number of set bits at that particular index plus 1. In the sense, 4 should contain the number of set bits in 4 should be equal to the same number of set bits in 1. One should this one should go to 0th index. Obviously, if this one should go to 0th index, obviously 4 and 1 should be swapped. If 4 and 1 are swapped, obviously 4 should contain the number of set bits that 1 has contained. Exactly. So 1 contains the number of set bits that 4 has contained. Then we can just simply swap. So number of set bits in 4 should be equal to the number of set bits in 1. In the same manner, number of set bits in 1, this one should be equal to the number of set bits, and this is the element of first index. That means element 2 should go to first index. Number of set bits in 2. Yes, the same manner, number of set bits in 3 should be equal to number of set bits at third index, in the sense the number 3. Exactly, number of set bits on in 2 should be equal to number of set bits at fourth index, and the value 4. If this is satisfied, I can just simply print true or else print false. Hope that is clear. Let us just simply convert this logic to code and let us see what we get. Let us code this up in Python. Let us first once again go with this input. It contains number of test cases, later the value, and later the array permutation p. Okay. So let us say something like let us say t is equal to into input, later I in range of t. I'm supposed to take n as input. N is going to be int of input. Later the permutation p is going to be a list of map of input dot split. And later, let us say I'm having some function def is let us say the permutation. sortable, and let us say the parameters that I'm passing here are array, the value n, and let us see if something else is required. We can just simply take it. Yeah, so I'm just simply calling this function, let us say, and let us just assume that the function is going to be a Boolean function which is going to return either true or else false. So if is permutation sortable, if this function with the parameters array p as well as the size n, if this is true, I'm going to print what is supposed to print yes and no. Fine. Let us say we are supposed to print else, else print no. Let us just implement this function. Implementing in this function in the sense, the logic is very simple. The value at that particular index should be having number of set bits same as the element index plus one. Element index plus one. So I need to count the number of set bits that particular number is having. So let me do something like this. I need to somehow iterate on the array. Let us say for I in range of n, if let us say count, let us say I'm having some function def count of set bits in the particular number n. So the easy way of finding the number of set bits in a particular number n, you can just simply take a count to be 0 in the very start, while n and n minus 1, if it is still greater, if it is still greater than 0, I can just simply increment my count or else not. So n, while n, I can just simply say increment the count and perform n equals to n and n minus 1. N is going to be performed as n equals to n and n minus 1, and count will be incremented each and every time. And finally, I'm going to return the count whatever I just got. Count. Return the count. Count to be 0 while n is greater than 0 in the sense while n, if it is greater than 0, count plus 1, n equals to n and n minus 1, and I'm going to return this count. So later, I'm just simply calling this function count of set bits on array of I. If the count of number of set bits in array of I, if it is not equal to count of number of set bits at that particular index, in the sense I plus 1. If it is not, in the sense I can just simply return false. Finally, I can just simply return true. Once again, the number of test cases iterating, calling the function is permutation sortable on the value array p as well as the array size n. If it is, you're going to print yes or else print no. So if it is in the sense the permutation is sortable, I'm going to iterate on this particular size n. If the count of number of set bits in the particular array of I, if it is not equal to count of number of set bits in I plus 1, I'm going to return false or else I'm going to return true once the entire array iteration is done. Count of number of set bits, a function to get the number of set bits in the particular value n. I'm going to iterate until the value n is greater than or equal to 0. Count plus 1. If n later, I'm going to modify n equals to n and n minus 1. I'm going to return the count. Let us run and see what we're getting to the output. So we got yes, yes, no, yes, 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 no, yes, exact same input, same output. Let us submit this. Yeah, all the test cases got passed. Moving to the next problem, make k most frequent. You're given an array A of n integers. You can perform the following operation any number of times. Select and remove any prefix or suffix of an array A, but not the entire array. Your goal is to determine the minimum number of operations required to make k the most frequent element in the array. It is guaranteed that k is initially present in the array. Okay, let us look at the input format. The first line contains the number of test cases. Second line n comma k, denoting n the number of elements, as well as the k the value what we are required, as well as third line contains array of integers a. If you look at the constraints, t, the number of test cases can go maximum 10 power 5, n can go maximum 10 power 4, and a of I as well as k will be always in the range of 1 to 20. Fine. Let us go with an example and let us see what we're actually getting. So let us take this example 11322. 11322. The array size is 5 and the value of k is equals to 3. 11322. So n is equals to 5, k is equals to 3, 11322 is the given example, and it was also mentioned output for this example is going to be 2. And let us see how we get. So as per the given problem, you're supposed to somehow remove the entire prefix, you're supposed to somehow remove the entire suffix and make the k most frequent element in the given array. Most frequent element. That means, and with this you're supposed to return how many such prefixes. In the sense, are you going to remove this entire prefix to make the k most frequent? Are you going to remove the entire suffix to make the k more frequent? So if you want to remove this entire prefix, this is one operation. If you want to remove this entire suffix, this is one more operation. In a sense, you're going to perform these two operations to make the k most frequent element in this particular array. So for this, you're going to say output is going to be true. Yeah, so that is the actual problem, and that is the expected output for this particular problem. Yes, and let us see how can we actually deal with this. Yeah, so if the example is 11322, 11322, if you go with the first prefix, so can I say this element is one of the first prefix? Yeah, if I somehow remove this element, the resultant array is going to be 1322, 1322. And what is the most frequent element in this array? The element is 2, but we are required k to be the most frequent element in this array. That means removing this prefix, this actually helps us? Obviously no. Let us increase this prefix from 0th index to 1st index, and let us see if it satisfies. So after removing this entire prefix, the resultant array is once again 322, and the most frequent element over here is once again 2. In the sense, removing this entire prefix is not making any sense to our output. That means maybe you're supposed to go for the suffix as well. Yes, going with the suffix, let us say I just removed this 2 as well. Let us say I just removed the suffix 2 as well. The resultant array is just 3 2. Then can I say 3, the element 3 is the most frequent element in this array, because the frequency of element 3 is 1 as well as the frequency of element 2 is 1. So I can just simply say the value k has occurred most frequent in this array with this particular operation. Yes, hope that is clear. I can also simply perform this operation from this to this, which actually makes me like 3 is only the element which is present, which makes it as the most frequent element which is present in this particular array. I hope that is making sense. Yeah. So this is one step, and this is second step, with the help of which we can just simply say 2 is output for this example. Not only this way, I can just simply go with simply removing this first element as the prefix and the second element, the last element, as the suffix, which in turn will result in 132, which has 3 as most frequent element in this particular array. But this is one operation as well as this is one other operation. So because of this, entirely the total number of operations in which the total number of minimum operations in which I can just simply make the value k, which is the most frequent element in this array, is going to be 2. I hope the logic is clear. Yeah. So moving forward with one other example, let us say, let us take an example 2212, 22112. So for this example 2212, yeah. So 2212. So 2212, n is equals to 4, as well as the k value, I guess that is given as 1 over there. Yes. So think in this way once again. If I remove this prefix, what can I say about the most frequent element in this particular array? Yes, the most frequent element is 2, but the value of k is 1. I need to make the value k as most frequent element in this array. So this is not the proper prefix which I need to remove. Let us remove these two elements as the prefix and let us see if it is making them if it is making the k as most frequent element. Yes, obviously frequency of 1 is 1 as well as frequency of 2 is 1. It is making the k as most frequent element in this particular array. In the sense, by just simply removing this entire prefix will actually makes us making the value k is equals to 1, which is the most frequent element in this array. I can just simply perform this operation with one step. So output for this example is going to be 1. Output for this example is going to be 1. In the same manner, if you also want to try in the reverse manner, if somehow remove this 2, once again 2, 2, 1, where frequency of 2 is greater than the frequency of 1, obviously this does not satisfy. If you try to remove this, the element whatever we required is being removed, so this doesn't satisfy. So removing from the prefix is actually making us the required output. Yes, so over here removing from prefix. In the same manner, what if I can simply reverse this entire array so that it is going to be 2 1 2 2. So for this third example, if we reverse this entire array like 2 1 2 2, so moving from prefix, removing elements from prefix doesn't make any sense in this particular array. So in this case, we're supposed to remove an element from the suffix. Yeah, so with the suffix we'll be getting output as once again 1. So I hope how we're trying to convert this particular array to make it the most frequent element of this particular array, the value k. I hope the logic is clear here, but if you also keenly observe what all possible output that we got over here, either I'm going to remove the entire prefix, but not the length of array. I'm not supposed to remove the entire array, maybe the entire prefix, maybe the entire suffix. For all these two cases, the output is going to be 1. Maybe some part from prefix, some part from suffix, which is actually resulting the output as 2. Output as 2. But what if we also take a similar different example? Let us say the fourth example, the value of n is equals to 3, and the value, let us say k is equals to 2, and the array is something like 1 2 3 1 2 3. So as it is 1 2 3, what can you say about the value k? Is it most frequent element in this particular array? Obviously yes. So as it is most frequent element, are we supposed to remove any of the two parts? We can remove to make it most frequent, but I want the minimum number of operations in which I can just simply make it. Obviously, with just simple zero number of operations, I can just simply make this value k as most frequent element. So for this, output is going to be 0. Yes. So if you keenly observe, either 1 could be the output, or else 2 can be the output, or else 0 can be the output. 0 can be the output. Yeah. So if you see, 0 can be the output. If you see, 1 can be the output. If you see, 2 can be the output. How can 0 be? How can 0 be output for this example? Whatever we discussed, just convert this into a simple step so that it will be very simple to understand. How can 0 be output for this example? The output 0 is possible only if k is the maximum frequent element which is occurred in this particular. In the sense, maximum frequency of any element of the array, if it is equals to frequency of k. So can I just simply say, if the frequency of k, if it is equals to maximum frequency of any element of this particular array, then the output is going to be 0? Obviously yes. If you see the frequency of this particular element, let us say it is 1. Yes, as it is 1, the frequency of the element 2, it is also once again 1. I can just simply say yes, because of this the output is going to be 0. If I also take something like 1 2 3 1 3 2 1 2 3 and 1 3 2, once again the frequency of element that has occurred, the value k is 2. Exactly same with other elements. Maximum frequency of any element is going to be 2, as well as this particular element is once again is going to be equal. As it is equal, I can just simply return 0 as output for this example. I hope that is clear. And later moving with 1, how can I say 1 can be output for an example? If you see, for this example, we just said 1 is output for this. And for this example, we just 1 is output. How can I say 1 is output for this example? Yeah. So if you can somehow keep track of the maximum frequency, as well as the frequency of the value k. And if both are being matched, I can just simply omit the remaining part, might be the right side part or else the left side part, which actually results the frequency of the element k, which is equal to frequency of other elements which has occurred maximum number of times. That means the value k has occurred maximum number of times in this particular array. I can just simply return true. In the sense, I'm going to either omit left part or else right part. I hope this logic is clear. Yes, in the sense, as we move on, we're supposed to take the frequency, maximum frequency of element, maximum frequency of any element as we move on in the array. So exact same logic, maximum frequency of any element as we move on in the sense the running array, if it is equals to the frequency, if it is equals to frequency of the value k in the same running array until that particular part. If it is same, I can just simply return 1 to my output. Same as frequency of k until that array, until that, in the sense, until in the same running array. If this satisfies, I can just simply return 1 by just simply omitting the right part or else the left part. If you see, for this example, 2122, for this example, 2122, yeah, or else for this example, 2212, 2212, the value of n is equals to 4 as well as the value of k is equals to 1. So if, as I said, running frequency in the sense, initially we got to 2, I'm going to simply store 2 and its frequency is 1. Okay, it's 2 and its frequency is 1. And once again we encounter this 2. As we encounter this 2, I'm going to simply increment the frequency from 1 to 2. From 1 to 2, and later we encountered a 1. As we encounter a 1, we are going to simply place 1 over here with a frequency of 1, and later we encountered a 2. As we encountered a 2, I can just simply increment this to 3. But at this point, at any of the point, is the frequency of the value k, is that equal to the maximum frequency of this particular? Obviously no, right? If you once again run in the same manner, initially 2 with a frequency of 1, and let me also do something like max frequency, which is equals to 1, max frequency which is 1. As we got once again 2, I can just simply replace this. The max frequency is going to be 2. Later we just got 1 with a frequency of 1, and later we got 2, the maximum frequency which we got already is 2 and this is 1. Later as we got 2, I can just simply increment this to 3 and the maximum is going to be 3. Is the maximum frequency equal to the frequency of k at any point? Obviously no. So for this I cannot say like I'm going to remove the left part or the right part, but this is all about going from left to the right in the sense in the prefix manner. But what if I go in the suffix manner in the sense from right to left? Let us also say do in the same manner. Let us say initially we are at this particular point, so frequency of 2 is going to be 1 as well as the maximum frequency until this particular point is going to be 1, and later we just got a 1 which has a frequency of 1. Now can I just simply compare the maximum frequency as a frequency of 1? Yes, obviously. Is like, are these two same? As they are same, I can just simply omit this entire remaining part. I can just simply preserve this part, and I can say 1 is the element k which has the maximum frequency in this remaining part of R. I hope the logic is clear. So with this, I can just simply return 1 to my output. If this is not the case, the final output is the only thing that is left over, that is going to be 2, because either this is the output or else 1 is the output or else 2 is going to be the output, removing the entire some prefix in the left, some prefix in the right, which actually results 2 as the output. Let us convert the exact same logic to code and let us see how it works. Okay, so over here I just took the entire part of input, something like a scanner, number of test cases, n as well as k, and reading for each and every element. This entire array v was constructed. I'm just simply calling calculate result a function with n, k as well as v as the parameters. N, k as well as v as the parameters, and whatever I'm getting from there, I'm going to simply print that particular result, what I'll just store in the result. Let us try to implement this function. calculate result. So as I mentioned in the very beginning, if the frequency of the value k, if it is equal to the maximum frequency of the array, I can just simply return 1. Sorry, I can just simply return 0 because none of the operations are required to make this entire operation. So for this, I'm going to take a hash map. Let us say map of integer comma integer. Let us say it is a frequency map. F map is going to be new hash map, Yeah, I'm just trying to take a hash map with the name f map of integer. So later I need to iterate on the array, take each and every element, put it in the hash map, get the frequency, get the maximum frequency. Obviously, if I want the maximum frequency, I need to initialize something to be 0 in the very start. So can I just simply say max frequency? Let us say this is going to be of integer int max frequency is going to be 0 in the very start. Okay, now I need to iterate on this particularly. Let us say for int I equals to 0, I less than n, I plus plus. So as I need to iterate on this particular array, what I'm supposed to do, I need to place each and every element into the map, which is f map. Let us say f map dot put. What I need to put the element, which is this is the array v. This is the array v. V of I is the element. What I need to place it now. So v of I, and with what frequency? With what frequency? If it is already present, some frequency might be already present. So let us say f map dot get or default of value v of I. If it is not, take it as a 0. If some value you got, just increment by 1. If nothing you got, it's going to be 0. 0 plus 1 is going to be what you're going to place it in the vmap. Vmap dot put v of I comma fmap dot get or default of v of I comma 0 plus 1 is what I'm going to place in the fmap. And whatever I just got might be the maximum. So why can't I update this maximum saying that max frequency is going to be math dot max of max frequency as well as whatever the element I just simply placed just before. What is that element? F map dot frequency of the element is going to be f map dot get. I'm sorry, get. Oh, what's happening? Get what frequency of what I'm going to get? V of I. V of I. Max frequency is going to be max dot max of maximum frequency comma f map dot get of V of I. Whatever the frequency that we got might be the maximum. I'm just simply storing it here. Once I'm done iterating on this entire array, what if I can simply compare the frequency whatever I just got might be equal to the frequency of the element k. Yes, so if I can simply compare, if f map dot get, it was clearly mentioning the value k will be obviously present in this particular array. So if f map dot get of k, in the sense we'll be getting the frequency of the value k which was already placed. Yes, if f map dot get of k, if that is equals to the maximum frequency f max frequency, if these two are equal, in the sense the element which has occurred, the element what is k which has occurred maximum number of times, and that is a maximum frequent element, I can just simply return 0 over here saying that the element has already occurred maximum number of times. So if fmap dot get of v of I, fmap dot get or default of v of I or else 0 plus 1, getting the maximum. If it is a maximum, I'm going to return 0. Yes, so this is the first step. As I mentioned, like 0 is one of the possibility. This is the one of the possibility. I can just simply get 0. And later, what are the possibilities for 1? The possibilities for 1, as I'm iterating on the array, the maximum frequency at some particular point, if it is equals to if it is equals to the frequency of the value k, I can just simply return 1, that is the output. Yes. So for this function, I'm just simply using check possibility function as well as check possibility reverse function. This actually helps us to go in the prefix manner. This actually goes in the reverse manner, in the sense suffix manner. So let me just simply call check possibility function as both are Boolean functions. Let us say if check possibility, I'm going to pass the value in the sense the array v value k. Let me also pass the value n, which is the size of the array. Let us say int n. Let us say int n, size of the array. If check possibility, if this returns true, what I'm supposed to do? I need to return 1 as the output, because maybe I'm going to remove the left part, or else I'm going to remove the right part. Okay. Yeah, this is all about the prefix part. And what about the suffix part? If that also returns true, maybe that also returns true, I need to return once again 1. So if check possibility in the reverse manner, v will be the same, k will be the same, n will be the same. If this returns true, I'm going to return 1. If this is not a possibility, once again, finally I'm going to return 2 as the output. Okay, let us quickly implement the check possibility function. As I mentioned, the only difference between the previous logic to the current logic, previously once entire map is done, I'm just simply comparing the frequency of the element k with the maximum frequency. But over here, I need to compare the frequency of the element k with the maximum frequency with the running frequency. Running, as you move on, I need to compare each and every particular one. So as I mentioned, I need a map once again. Let us say map of integer. Let me just simply copy, or anyways, like integer, let us say f map is going to be new hash map, so I'm just simply taking a map which is f map, which is of integer, a pair integer, and later I need to place each and every element of the value of the array v. So let me just simply iterate for, let us say, int I equal to 0, I less than n, I plus plus. So I need to place this element. Let us say f map dot, sorry, put, f map dot put, v of I is the value what I need to place, and the frequency. So f map dot get or default, if it is not present, okay, double g, f map dot get or default of v of I with v of I. So maybe v of I, if it is not present, exactly same like previous, if it is not present, this returns 0, uh, plus 1 is what I'm going to place it in this fmap. Fmap dot put v of I comma fmap dot get or default of v of I comma 0 plus 1 is what I'm going to place it in this map. So once I'm done placing, I need to check the maximum frequency. So exactly same, once again, can I just simply take int max frequency to be 0, and maybe the maximum whatever we got, maybe the maximum, right? So max frequency is going to be math dot max of max frequency comma this value whatever we just inserted, f map dot get of v of I. Okay, so once we got this maximum frequency, so what if you can simply check if the maximum frequency whatever we got might be equals to the value k, in the sense might be equal to the frequency of the value k. So over here itself, I'm going to check if max frequency, if that is equals to f map dot get or default, because maybe the value k might not be inserted in the very beginning itself. So get or default of the value k with 0 might not be present 0. If fmax dot get or default of k comma 0, if these two are equal, what I'm supposed to do, I can just simply return true. Yes, But once I'm done iterating on this entire array, but I couldn't find any of the frequency which is matching with the maximum frequency, I can just simply return false, false. Yeah, exact same logic, even for reverse manner. So this is for moving from left to right. In the same manner, what if I'm moving from right to left? If I'm moving from right to left, instead of iterating from 0 to 1, I need to iterate from n minus 1 all the way from n minus 1 to it is greater or equals to 0, and to decrement each and every time. I minus minus. Place this value. If it is not present, just place 1 to the frequency. If it is present, get the frequency and increment it. Get the maximum. If the maximum, if it is equals to the value k, return true. Once you're done with iterating the entire array, you can just simply return false at some particular point. If it returns false, maybe this is going to return false and maybe this is going to return true. So obviously you're going to return 1 to the output, or else if both return false, I'm going to return 2 to the output. Yes, let us once again verify something. Yeah, maximum frequency get all default false, false. Yeah, let us quickly run this. So we got some output. Let us compare with the input and also, yeah, 00012, exactly same whatever we got. Yeah, let us submit this. Yeah, all the tests got passed. Moving on to the next problem, constant subsequence. Alice has an array of length n, and her goal is to rearrange the array in a way that to minimize the maximum subarray sum of the resulting array. Okay. However, Alice must keep the relative order of non-negative and negative elements the same as the original array. It was clearly mentioned like non-negative elements as well as negative elements, the relative order should be preserved. Yeah, and you're tasked with finding the minimum possible value of maximum subarray sum after rearranging array according to these results, these rules. Yeah, so note sum of an empty subarray is 0. Okay, if you can simply take a empty subarray, the sum is going to be 0. So that is also one thing that was mentioned here. Let us take an example for better clarity. For the first example, 1, 2, minus 1, minus 2, the output is going to be 2. And let us see how we get 2 as output, and let us dive into this. Yeah, the input size n is going to be 4. The array is given something like 1, 2, minus 1, minus 2. So 1, 2, minus 1, minus 2. So for this particular example, it was mentioned like you can rearrange the elements, but the relative order of positive should be exactly same, as well as the relative order of negative should be exactly same. And out of all these arrangements, you need to get the minimum of all the maximum subarray sums. Let us see how can we form all these arrangements, and let us see how can we get the minimum of all the maximum subarray sums. Okay, as mentioned, like I am going to take 1, 2, 1, 2 as all the positive elements, as well as minus 1 as well as minus 2 as all negative elements. So order should be preserved. So for now, one of the possibility might be I can just simply take 1. I can just simply start with a 1, and later I can go with a 2, and later I can just simply go with a minus 1. I can just simply go with a minus 2. And one other possibility, I can just start with 1. I can go with minus 1. I can go with 2. I can go with minus 2. This is another possibility. And might be one other possibility, I can just start with 1. I can go with minus 1. I can also go with minus 2 and later with 2. So this is one other possibility. Yes. And moving in the state in the same order, what if you can simply start with negative elements? If I start with the negative elements, 1 should come before minus 2. Sorry, minus 1 should come before to minus 2. That is a relative order that we are supposed to preserve. So I can just simply start with minus 1. Later, I can go with minus 2 and later 1 and 2. So this is one way. I can go with minus 1, 1, 2 and minus 2. And one other way, I can go with minus 1, 1, minus 2 and 2. So these are all the different ways of arranging this such that the relative order of positive as well as the negative elements will remain exactly same as in the original array A. And out of all this, it was said that get the maximum subarray, get minimum of all the maximums. I hope the logic is there. Get the maximum subarray, get the minimum of all the maximum sums. In the sense, what is a maximum subarray sum in this particular example? It's going to be 3. And what is the maximum subarray sum in this particular example? It's going to be 2 just. If you can simply include 1 and minus 1, it's going to be 0, and later 2, it's going to be 2. Or else if you can simply take 2, that's going to be 2. Yeah. In the same manner, over here, it's going to be 2 over here, maximum subarray sum. Don't just remember, we are keeping track of maximum subarray sum. So it's going to be 3 over here, it's going to be 3 over here, it's going to be once again 2 over here. And out of all this, what we are required? If you once again look at the problem, see, you're tasked with finding the minimum possible value of maximum subarray sum. Minimum possible value of maximum subarray sum of all these arrangements. In the sense, after rearranging, these are all the possibilities, these are all the maximum subarray sum for each and every possibility, and out of all these possibilities I need to get the minimum possible sum. And out of this, what is the minimum? The minimum is going to be 2, and 2 is output for this example. 2 is output for this example. Let us look at this. Yeah, so for the first example, so 1 2 minus 1 2, the output is 2. Output is 2. How can we get this? So this is one way of generating all the possibilities, in the sense generating all the arrangements after rearranging, and you can just simply get the maximum subarray sum for each and every particular array and get the minimum of all this. This is one way of solving. But if you also look closely into this particular problem, it was mentioned like output and a line minimum possible value of the maximum subarray sum. Minimum possible value of the maximum subarray sum. Don't you see this is a regular pattern of binary search? Minimize the maximum or else maximize the minimum, minimax, maximin problems. Yes, so this is a regular pattern of binary search which includes saying that minimum possible value of the maximum subarray sum. Out of all the subarray sum, get the maximum, get the minimum of all those. This is a very general regular pattern of binary search. We can just simply include over here, saying that at some particular point, if 10 is answer, maybe a smaller one towards the left of 10 may be the answer. You're going to store this 10 and search for the better answer on the left side. So this is what we generally do if you want a minimum of the maximums. Minimum of the maximum. Yeah. So we can just simply go with the same approach. But how can we say a particular arrangement is going to be valid so that I can just simply go with this mini-max approach? Yes. So for this question, I'm just simply going with a simple example. Let us say I'm having only 2 elements, and those 2 are something like 4 as well as 2. If 4 as well as 2 are present, what can you say about the maximum subarray sum? Obviously, it's going to be 6. Yes, obviously it's going to be 6. Over here, what if I want to include a negative element into this? Let us say the negative element which I want to include is going to be minus 2. Okay, now the resultant array is something like minus 2, let us say 4 2, minus 2 4 2. Now let us assume like this is the given array for you. This is the given array. What can you say about the maximum subarray sum over here? Obviously, once again, 6 is going to be the maximum subarray sum. But if you once again try to rearrange it a little bit, let us say this is a minimum, sorry, this is a negative value. So what if I can somehow rearrange? This is one form of rearrange. What if I somehow rearrange something like 4 minus 2 as well as 2? 4 minus 2 as well as 2. And what do you say? What do you say the maximum subarray sum over here? It's going to be 6. And what do you say maximum subarray sum over here? If you try to include the entire array, it's going to be 4. If you try to include only this 4, once again, it's going to be 4. Yes, 4. And what is other way in which I can just simply rearrange? Yes, I can just simply go with this something like 4 2 and minus 2. So if I go with 4 2 and minus 2, now what do you say about the maximum subarray sum? Once again, it's going to be 6. That means you are getting out of these 3 possibilities, just consider these 3 possibilities. Yes, out of these 3 possibilities, you can get the minimum, subarray sum, in the sense you can these arrangement these all these three are the different arrangements. Out of these three different arrangements, getting the maximum sub and getting the minimum of all this is one way of doing. Instead, we are only required of this particular smaller value, in the sense the minimum possible subarray sum, minimum possible subarray sum. But if I want to get this minimum possible subarray sum, it is clearly, like, we can just simply understand by this something, a positive number should be followed by a negative number, in the sense a larger number, maybe if it is followed by some negative number, because of which maybe if it is exceeding some particular range, we can just simply get back to some particular thing. Yes, so for this reason I can just simply include 4 minus 2 and this is 2. Yeah, so the intuition is very simple. If there are few positive numbers over here, if there are few more positive numbers over here, the only thing I can just simply include this entire subarray to get the maximum, in the sense the minimum of all the maximums that is possible. If I can somehow include few negative numbers in this particular part. If I include few negative numbers in this particular part, I may be having a chance of getting a smaller maximum subarray sum. I hope the intuition is clear, because if this is one of the case, if this is an entire negatives and this is the entire positives, I can just simply include this particular part. I can just simply say this is the maximum subarray sum, but I want the minimum of the maximum subarrays, and I can just simply say, like, if this part is entirely of positives and the leftover part, if this is once again negative, this is once again the exact same scenario. I can just simply include this particular part, the right part, sorry, the left part, and I can say this is what the maximum sum is. But once again, with the minimum of the maximum sum, which is possible only in this particular case, where if I can simply include few positives on the right, few positives on the left, and few elements in between, which are going to be minimum, so that I can just, sorry, which are going to be negative, so that I can just simply get a minimum of the maximum sum. I hope the intuition is clear. Let us move on with the same intuition to somehow convert the logic to code. Yeah. So, so this we are going to code in Python. So as of now, let us go with the input format. The first line of input will contain t, the number of test cases. So each test case contain a multiple line of input. The first line of each test case contains n, the length of array. Second line contain n space of integers. There is array. Okay. So let us say for I in range of int of input. This is reading test case, and I'm going to iterate for those many number of times. But I in range of int of input, what I'm supposed to do? I need to read the value n. N is going to be input, and next the array. So let us say lst is going to be list of map of input dot split. Okay, so I'm done with taking this n as well as lst as input. Later, as I mentioned, if I can somehow segregate the positives as well as the negatives, I can just simply include a positive. If it is exceeding some particular range, I can just simply include a negative, include a positive, include a negative, or else include positives until if it is exceeding the range. If it is exceeding, include a negative. So for this reason, I need to segregate all positives aside as well as all negatives aside. So for this reason, let us say positives is going to be an empty array, as well as negatives is going to be once again an empty array in this way. And later we need to populate these positives as well as negative arrays with all positives as well as negatives respectively. So for this, I'm going to iterate on this array. For I in, let us say, lst, if I, if it is greater than or equals to 0, I can just simply include, let us say, instead of positive, it was clearly mentioned like non-negative, n negative, let me mention like n negative, and this one more is going to be just negative. So if I is greater than 0, what I'm supposed to do? I need to include this in non-negative, n negative dot append of this particular number I. Else if this is not the case, negative dot append of this particular number I. So with this, I'm done with getting all positives as well as all negatives, all positives and all negatives. And what is the thing that is left over? Somehow I need to find the minimum of all maximums over a sum, minimum of all maximums over a sum, and which is possible if we can somehow rearrange in this particular pattern as I mentioned, like positives, negatives. Yes, so we can just simply go in this particular pattern. But as of now, if I say, so if you look at the previous example, if you look at this particular example, so 3 is also an output, 2 is also an output, 3 is also an output. Out of all these, if someone says like 3 is output, obviously 3 can be the output, but 2 is a better output than compared to 3. Hope you're able to understand. 2 is a better output than compared to 3. That means we can just simply go on with 3. If 3 is possible, store this value 3 and go for the better possibility of 2. So I can just simply go in this particular way. So for this, which I'm going to use a binary search. And for applying binary search, always, as we remember, we need few things. One is the least possible answer, one is the highest possible answer, and with this we're going to calculate mid. Okay. So what do you think is the least possible answer? Least possible answer. If you look this particular array, it's just like -1 as well as -1. Two elements which are -1, -1. So as the elements are -1, there is not all required, nothing to do with this particular thing. So output for this is going to be 0. So I can just simply include a least possible, let us say low is going to be 0 for this, and highest possible in the sense entire positives array, in the sense entire non-negatives array sum. Okay, so high is going to be sum of n non-negatives. Okay, I'm going to take the least possible from is going to be 0, and the highest possible, that is going to be sum of entire non-negative elements. Sum of entire non-negative elements. Yeah. So with this, I'm going to go with the binary search. So while some condition is true, in the sense while low less than or equal to high, you're going to calculate mid. So mid is going to be, let us say, low less high by 2. So you're going to get the mid. Mid is going to be low plus high by 2, low plus high by 2. And we all know if 3 can be answer, store 3 and search for the better answer. Okay, how can you say 3 may be answer? So that is what we're going to implement some function which actually helps us to find whether 3 can be answer or not. Let us say a function with name valid or is valid, function is valid, which actually takes positives in the sense and non-negatives and negatives, as well as whatever the mid, whatever answer that we assume may be the answer, so mid. Okay, so over here you're going to check, this is a boolean function which actually says maybe mid might be answer. If mid might be answer, you're going to store it and search for the better answer. Yes, you're going to store it and search for the better answer. So over here, let me say I need something like answer to store this, and initially I'm going to store the highest value as my answer. So if this is answer, I'm going to update answer as answer is going to be m, and I need to search for a better answer. So as I mentioned, like if 3 is answer, yes, 3 can be answer. Search for a better answer. So for a better answer, we need a smaller one compared to 3. Yes, smaller one. So if I want a smaller one, I need to search on the left side. If I want to search on the left side, I need to move a high pointer. High is going to be mid minus 1. So I can just simply say high is going to be mid minus 1. High is going to be mid minus 1. If this is not the case, I'm going to go with a low equals to mid plus 1. But I need to check if it is valid, right? If it is valid, I need to perform this operation. So before do this, let me just simply cut this. I can just simply include the function whatever we wrote is valid. Is valid. We are having the positives, not the positives, and negatives, non-negatives, negatives, and later the value mid whatever we got. If it is valid, I'm going to update answer. I'm going to update answer and search for the better answer on the left side, which is going to be high equal to mid minus 1. If this is not the case, I'm going to search for a better answer, in the sense maybe this is not the correct thing. I need to increment my low pointer so that I need to search on the right side. This is not an answer, but I need to search on the right side. Whatever we got, this is not valid. If it is not valid, I need to search on the right side. Maybe this is so small. I need to search with the bigger one. So for this reason, I'm going to say something like low is going to be mid plus 1. And this is not the case. Low is going to be mid plus 1. Yeah. And finally, whatever the answer that we got, I can just simply return. Okay, over here, I can just print the answer whatever I just simply got. Let us implement this valid function. If I want to implement this valid function, as I mentioned, I'm going to include positives until it is exceeding the value m. Until it is exceeding the value m. So as we're having negatives, non-negatives as well as negatives, I can just simply iterate on this. So let us say I'm having a pointer, let us say p1, which is pointing to 0, which indicates we are at what index in the non-negative array. Okay, let me also take one more pointer p2, which is pointing at 0th index, indicating that we are at what index we are pointing on negative element. Okay, p1 as well as p2. So obviously if I want to include negative elements into this, obviously the pointer p1 should be less than the length of non-negatives, as well as pointer p2 should be length of negatives. Yes, so let us say while p1, if it is less than length of n negatives, non-negatives, and p2, if it is less than length of negatives. If this is the case, what I'm supposed to do, I can just say that I include p1 or else p2, array of p1, in the sense negative or non-negative of p1, negative of p2, either this or else this. And obviously until this is less than mid, I can just simply include this, right? Until this is less than mid, I can just simply include this. So while p1 is less than length of negative as well as p2 is less than length of negative, I can just simply go with this. If when I'm trying to include this non-negative element, if it is exceeding, then I'm supposed to include a negative element, right? So for this reason, let us say over here the sum we got s is going to be 0, which we can simply take. As of now, the sum we got is going to be 0. So can I just simply say if s an element from non-negative, how can I get this element from non-negative? N non-negative of p1, if s plus non-negative of p1, if it is exceeding m, that means if it is exceeding m, I can just simply go with this. Let us say my value of m is something like 5. Let us say the elements that we have taken until this is going to be something like, this is going to be positive or else non-negative, and this is going to be negative. The elements here are something like 1 1 4 or else 1 4 3 2. Over here something like -1 -2 3, sorry, -3. Yeah, let us say something like this. So if I can somehow include value of m is equals to 5, if I take 1, this is valid. If I can simply take 4, this is also once again valid. And when I go with 3, this is not valid. That means I'm not supposed to include this 3. But if you go with this 3 and 2, 5 is the resultant output, which is even more, like which is evenly exactly same like the 4 plus 1, and which is equal to 3 plus 2. I can just simply add it to get the maximum possible. Yes. So if I want to add this, obviously I need to take a negative element over here. So what if I can simply cancel negative element, which is going to be -2, which is in turn it's going to be 5 minus 2, it's going to be 3. So 3, as it is 3, let me check once again. Can I just simply take this 3 over here? Yes. So 3 plus 3, it's going to be 5 over now. 5. Once again, I cannot include. I'm going to take -3. So -3, and this is going to be entirely 5. Now I can just simply go with this 3, and I can just simply go with this 2. Yes. So this is one way. If I can simply take, instead of this -3, if I can simply take -2 over here. So over here, as of now, the sum we got is going to be 5, and later it's going to be 3, and later if I can somehow include -2 to this, it's going to be 1, it's going to be 1, and later if you include 3 as well as 2, it's going to be 6 in total. Because but instead of including this -2 as well as 2, if I can simply only take this, we'll be getting a maximum sum. But we know the minimum of all the maximum sum. If you want the minimum, I need to include these elements, as I mentioned, I need to include these elements in between some elements. So which actually gives us 6 as the minimum of all the maximum, which I can just simply get in this particular arrangement. Yes, yeah. So going back to this. So if s plus this particular non-negative of p1, if it is exceeding, what I'm supposed to do? I need to include a negative value. So I can just simply say s plus equal to negative of P2. Once I'm done with this, I can just simply include, yes, I can just simply increment my pointer P2. So P2 plus equals to 1. Yeah. So this is one thing. This is one thing, but if you can once again look into this, what if I say, what if I say, I'm having 1, 4, I'm having 1, 4. Over here, instead of minus 2, what if I say something like I'm having minus 6, minus 3. Okay. So after 1, 4, if you try to include this 3, it is going to be exceeding this value 5. It is exceeding this value 5. But what if I include this minus 6? If I include this minus 6, it's going to be 5 minus 6, which is equal to minus 1. Do I need to continue this minus 1 for the next sum, like next sum? If I continue with this, we'll be getting a very minimum, right? Very minimum. But we know the maximum sum, maximum summation. Out of all the maximums, we win the minimum in this particular arrangement. So obviously, if you are getting negative, if you're getting negative, always we are having a chance of once again making it back to zero. In the sense, we are going to ignore this entire part and we're going to move with the leftover part, that is 3 as well as 2, which actually gives us 5 as a output. Yes. So for this reason, if the value exceeds beyond 0, in the sense, if it is exceeding beyond 0, I can just simply say s is going to be max of s comma, so it is going to be max of s, whatever we got until this particular point, comma 0. It cannot go beyond 0. For this reason, s is going to be max of s comma 0. So if this is not the case, if this is not the case, that means whatever we are including, it is less than m. That means we can just simply include the positive, right? And this is non-negative. So under else, I can just simply say s plus equals to non-negative of p1, and I can just simply increment my pointer p1 plus equal to 1. Yeah, so this is one thing. I can just simply go with either negative or else positive. I can decide only based on one particular thing. If that is greater than m, I'm supposed to include negative. If it is not greater than m, I can just simply go with a positive value. Yes, so this is done. And moving further, yeah. So let us say 1, 4, 3, 2 is present and minus 1, minus 2 are present. Minus, let us say minus 2, minus 1 are present over here. So 1, 4, 3, 2, minus 1, minus 2. So if I try to include this 1, 4, 3, 2, minus 1, minus 2, or else let us say a few more elements also present, 5, 3, 6, 5, 3, 6. So for this particular array, for this particular non-negatives as well as negatives, once if I go with this 1, 4 with the same value m is equals to 5, 1, 4, later obviously it is exceeding with the included 3. I'm going to include minus 2, and which is going to be 3 now, and which once again if I take 3, once again it is exceeding, exceeding. Once again if I take minus 1, it's going to be 2. 2 plus 3 is going to be 5. I can just simply take this. Once I'm done taking this, but I'm not having any elements in this particular array which I can just simply take it, because whatever elements that are present, I have already taken them. Minus 1 as well as minus 2. Minus 1 as well as minus 2. But if I want to get the maximum subarray sum, in the sense, we need the minimum of all maximums, but if I want to get the maximum subarray sum, I'm left off with including all these elements. Yes, obviously I can just simply include all these elements. It's going to be 2, 5, 3, 6. 2, 5, 3, 6. But my pointer P1 is still pointing here, and pointer P2 exceeded, and pointer P2 is pointing here. That means I'm supposed to include even these elements. For this, I can just simply do something like this. While the pointer, so based on some condition, I have exceeded this particular, the while loop has failed, but I'm still having few elements in this particular array. So for this reason, while P1, if it is still less than length of non-negatives, if it is still less than this, I can just simply s plus equals to non-negative of P1, non-negative of P1, and I can just simply go with P1 plus equals to 1. Yes. So with this, I'll be getting all non-negatives as well as I'll be getting, like, I can include all non-negatives. I can include all negatives with the help of incrementing the pointer P1. Yes. So once I'm done with this entire process, I can just simply check if my value s, if it is less than or equals to mid, I can just simply return true, or else I can just simply return false. That is an entire logic. I can just simply say if or else I can just simply return s less than or equals to m. If it is less than or equals to m, that means this is a valid thing. If it is a valid thing, store it as an answer, store it as an answer, store it as an answer, and search for the better one by by decrementing the height pointer. If this is not valid, go for an answer on the right side by incrementing low pointer. So finally, whatever answer we are getting, I'm going to return it. I'm going to print this answer. In this particular function, this is going to return either true or false, indicating that s is less than or equals to m or else greater than. Yes. Let us try to run this and see what we're getting to the output. So we got 203, exactly same what we expected. Let us submit this. Yeah, all the test cases passed. And that's it for this video. And for more content, subscribe to our YouTube channel and also let us know in the comment section what all cool stuff you're interested in. Thank you.